This short trailer will give a brief brainstorming of how a most fundamental Turing machine, a universal computer, might make this world a better place. Enjoy watching it and feel free to write comments or get in touch with us on worldformulaapps.com to discuss, present ideas, or come forward with project plans. In December 2019, a new coronavirus emerged in China, and within 6 weeks only, more than 20,600 people were infected and 427 people died from that respiratory illness. In our globalized world, the virus spreads fast, and scientists around the globe are racing to understand and fight the deadly enemy. There are fears that the virus, which seems to transmit more readily between humans than SARS and has a pretty long incubation period, could develop into a pandemic. Scientists are trying to find ways for early diagnosis and vaccine as fast as possible. But will they be fast enough to win the fight against the incomputable enemy? You have cancer. The diagnosis often comes out of the blue and always tears the ground from under your and your family's feet. Hospitals, treatments, chemotherapy, surgery. The next month or years will be very different and far away from a normal, everyday life. Nowadays, cancer is treated with a great variety of modern means, but probably every honest doctor on this planet would agree if we state that the perfect treatment wasn't found yet. All known options have often terrible side effects, do not guarantee lasting healing, and can mainly only be delivered via painful and partially even inhumane procedures. It therefore has to be concluded that the current situation is far from good or satisfying. Even in cases where the patient can be cured, the suffering and the side effects caused by the state-of-the-art measures are too often unbearable. And there are also so many cases where all known methods fail. A perfectly side-effect-free and painless treatment is seen in the so-called monoclonal antibodies. Here, however, we have to adapt a complex organic system, namely the monoclonal antibody, to a single and always very individual counterpart. In other words, not only every patient is unique, but also his or her cancer is. This renders the task of analyzing the cancer and patient genome and finding its perfect antibody solution a 10 to the power 24 faculty problem at least, and requires all computers in the world put together to work for many years only for one patient alone who has only one specific type of cancer. This is because we are not only talking about simple gene code optimization problems where we only need to find the right fit for the antibody to the cancer. Unfortunately, nature apparently is also writing between the lines, and so the genetic code alone is not the whole task. The proteins coded by the genes is one thing. The correct environment, presence of agents, catalysts, and fields to synthesize, and what often is much more, to fold them into their only suitable biological form is quite another. The sheer number of structural possibilities to the same chemical composition and the complex nature of human tissue renders the task of finding and constructing optimum and truly satisfying solutions impossible by classical means. What we need is not only a better understanding of the materials, dynamic processes and interactions, but more computational power to allow for brute force calculation of multidimensional problems arising with this application. Within only a few years, Dr. Schwarzer has published a huge variety of works which have mathematical answers to many different questions. Within those, answers and opinions are not decided, made up or felt, they are calculated. His recent book, The Theory of Everything, gives the theoretical basics and most fundamental starting point. Richard Feynman once said that in order to calculate and understand a quantum object, one should build a quantum computer. Our reality, however, is a quantum gravity one, and thus, in order to completely understand it, we better build a quantum gravity computer. In understanding the fundamental theoretical principles, and along the way laying open its core features, hides the best chance mankind has to develop a tool that will help to solve many world-shaking problems. Based on the assumption of a minimal principle, Schwarzer succeeded in showing that quantum theory already resided inside Einstein's general theory of relativity and united the two. The thing we want to concentrate on here is the question about the most fundamental computer machine there could be within this universe. Based on all those cumbersome calculations, complex formula, and complicated steps to quantize the universe, Schwarzer sees a very promising way for the realization of a powerful processor for the first quantum or even quantum gravity computer. But why all this fuss about the quantum computer? What is so special here? Well, while the classical computer can only handle zeros and ones, which is to say 2 different states, the quantum computer uses reals and does all possible states in just one circuit time. This gives an immense calculation power in comparison with the classical machine, at least for a variety of tasks. But having now also a metric approach for the understanding of the inner working of such a bit, we do not only see how the computer does achieve this all-in-one-moment calculus, but we also realize that such machines could be even more powerful. In fact, one might come to the conclusion that the intrinsic power of a single Einstein quantum bit could be the one of a whole universe, and it even could be a universe of its own. To conclude, coronavirus, cancer and strokes are only some problems that could be treated in a much more patient-friendly way with the help of a quantum gravity computer. There are many, many more. The limit is our imagination. And even if there are still open questions, some unsolved problems and probably a long way to go, this surely is a good starting point and currently the best chance we have. We thank you very much for your time and your attention.